This video is entitled Intelligent Systems and goes along with Chapter 13 of our course, BUIS 2100, An Introduction to Information Systems. I'm Dr. Renaud from Shawnee State University, and I'll be taking you through this brief video introduction. So let's talk about intelligent systems, and we'll start by introducing the term artificial intelligence. What is artificial intelligence, or AI? Well, it's computer programs that work more like the way the human brain works. They're not exactly rules based. Some of them are learning machines. Some of them do things fuzzy. There are lots of different techniques, but um, what we use them for, we use them in situations where we need knowledge or perception. For instance, trying to find a face in an image that requires perception, reasoning, understanding, and some kind of cognition. Usually, artificial intelligences are used in generating or displaying data. And we use them in what is and what if games. So let's stop and think about what a what is game. I give you something and you got to figure out what it is. Or I give you a scenario and we play what if. What if this happens? What if this happens? What if that happens? Those are strong areas where artificial intelligence are being used. So, one type of intelligent system we're all going to be dealing with now and into the future are robots. And when we think of robots, we think of little Asimov or these robotic arms. But robots exist in lots of places. Think about the self checkout at Kroger, how it counts money and delivers money and can make change. Well, that's a robotic function. Robots are really good at repetitive work, um, things that we can automate, things that we can do a lot of. Robots are really, really great in dangerous environments. You know, sending a camera guided device into a dangerous, into a nuclear reactor, into diffusing a bomb, all of those kinds of things. So robots are really wonderful in dangerous environments. And another advantage with a robot is they don't have human issues. Um, there are kind of two different types of robots. There are the hard robots and the soft robots. And I don't mean tactically hard or soft. I mean, um, soft robots do packing and picking and robotic assisting, where autonomous and hard robots actually are doing things all on their own. You know, stop and think about the surgery robots that the doctors use that are like a set of hands, but they are controlling and guiding it at all times as it's doing very fine work with the doctor's larger motions. So you'll see a lot of this, and robots will continue to uh, to be more and more prevalent in society and in industry. There's another type of intelligent systems, and we call these expert systems. What an expert system is, it mimics a human expert in their very specific expert areas or tasks. Usually it's made of a group of algorithms to solve complex but programmable tasks. So, auto graders, map analysis, exploration. And they're based upon what we call heuristics or rules created from past experience. So we create a series of heuristics, rules, and we code them into a computer system. And once we do, that system is stable. It doesn't grow and modify. It's not self-modifying or any of that. But it's an expert system because it has the knowledge of an expert. An expert system is really made up of five kind of large bits and pieces. And the first would be the knowledge acquisition part of an expert system. And those can be manual or automatically, the acquisition of knowledge can be manual. Somebody feeds it the information, or it may be connected to sensors or databases or external data sources, and that acquisition of knowledge becomes automatic. For instance, if you have a knowledge and expert system that helps you purchase items, an automatic feed of pricing, an automatic feed of the consumer price index, an automatic feed of catalog pricing may become an important part of that expert system, or it could be manual. There's a knowledge base, which is kind of similar to a database, but it holds the facts, it holds the rules, and then it holds meta information or information about information. The third part would be the user interface that the actual human being uses to interface with the system. There's often in an expert system an explanation facility. So after the expert system comes up with an answer, um, you look at the answer and go, well, yeah, I get it, but how did it come up with that? So in the user interface, there's most often an explanation area where you can go in and you can see that this factored in this way and this factored in this way and this rule was used for this and this rule was used for that. Really kind of cool, so that you can make sure your expert system is still being an expert. And most expert systems include an inference engine. And inference means to ask questions. And there are two different ways an inference engine can be used. One of them is a forward inference, and one of them is a backward inference. Let me give you some examples. A forward inference is an if then. If we do this, what's the result going to be? If the price of this goes to this, what's the result going to be? If this and this environmental thing happens and this happens, what's the result going to be to our cost or to whatever our expert system is doing? There's also the backward inference where we start with a goal and we say we want to get to this, and then the expert system adjusts all of the factors underneath to try to get to that goal. And then maybe we have to use management and other skills to make our business work so that we can, but it kind of starts with a goal and works backwards. In backwards inference or forward inference, we start with a series of assumptions and see what the final result would be. Systems can be used really in lots of places where we have a well-defined problem that's often more than one person can reasonably do. Um, there have to be rules, but not too many rules to pull off an expert system. Now, don't use an expert system if it's purely numerical, because if it's a purely numerical kind of analysis, you can do that with a spreadsheet. If the rules are poorly defined, or you don't really have good formal rules for how to do something, then you really can't program it into an expert system. And if you have disagreement between your experts, one expert says we do it this way, another expert says we do it that way, and your experts won't agree on how to do it, then writing an expert system might not work. Now, that disagreement might be kind of fun because you can put in both sets of rules and then have your expert system run the two, and then you can compare the results. Maybe that's an interesting way to use it, but don't use it if it's a purely numerical or if the rules for how experts actually solve the problem aren't really fully understood. So there's another type of system known as an intelligent agent. It's kind of a little smarter than an expert system, but it's still rules based. You give it a series of rules, and it then reasons which rule to use when. Um, Rules based reasoning. Usually it's used for bots and virtual agents. They're adaptable, usually autonomous, and maybe a little bit more humanish than an expert system. They're used in online sites for marketing and customization and cataloging. They're used in data mining. They're used in equipment and logistics tracking. They're used in lots of different areas where you have a series of rules, and some rules apply, some rules might not, and the intelligent agent gets to kind of pick and choose which rules get combined to come up with an answer. So that's another type of system, intelligent system. Another type of intelligence system, or another category of systems that are intelligent, are machine learning systems. And machine learning systems learn a lot like the human brain does. They learn from experience. So what happens is, and you see the picture down here at the bottom, there you go. You see the picture. Basically, data is given to the expert system, and the expert system has a whole series of neurons or processes that are internal and hidden from the programmer and hidden from the user. And the expert system then gives us output. We then look at that output and say, well, the output's wrong. We then feed that data about success or failure, or how right it is or how wrong it is on a scale of rightness and wrongness, and feed that information back in, and the system actually starts to learn. Um, it uses that feedback loop to to create a a system that we really don't know exactly what it's doing inside. It doesn't have an explainer function. It just kind of works. For instance, um, have you ever noticed just how good um, Netflix is at recommending movies to you? Well, they use a machine learning expert. They use a machine learning system that takes a look at all of the movies you've watched. Um, and they look at all of the movies other people watch. So if you watch a movie and you sit all the way through it, and you watch another movie and sit all the way through it, and there's somebody else in the world that's done the same two movies, but they've also done a third movie you haven't, then they're pretty sure you might like that third movie. Maybe you binge watched this series. Well, these thousand other people have been binge watched that series, and 800 of them have binge watched this other series. So they'll suggest that series to you. Um, those kind of rules aren't directly programmed into the system. Those are a feedback and learning machine learning system that's actually learned what you like and your preferences, and based upon all the other people who like and their preferences, kind of can make inferences about what you will possibly like in the future. Facial recognition is another place where machine learning has been used to show machine learning a picture and then say, well, those are eyes, that's a nose, that's a mouth, those are ears, that's top head, that's a chin. And then you show it another picture and you tell it those same things. And you show it another picture and you train it with 1,000 pictures. You train it with 10,000 pictures. And it's able then to look at a new picture it's never seen before and pick out a face. Really kind of cool stuff. Speech to text, being able to convert the spoken word into the printed word or the written word. Optical character recognition or handwriting recognition is also a good example of things that machine learning is being used for, and self-driving cars. Imagine the complexity of writing a program to tell a car how to drive. But what if you have a machine learning algorithm that is able to, this is driving correctly, this is not driving correctly, and you literally teach the car through a series of feedback. Here's the input, here's the output, here's the feedback that goes with the output back into the input to either reinforce or disenforce, or dismiss that behavior. And these neural networks will actually learn. That's some cool technology and some cool stuff. There's another type of intelligent system known as a genetic algorithm. And a genetic algorithm is really a little too complex for me to spend a lot of time on, but I just wanted you to know it exists. Basically, what you do is you create a series of random solutions, and you pick the best of those random solutions. You then mutate, select, and merge and cross over the bits of the generic of the random solutions. And then you pick the best ones again. And you do it again by mutating, selecting and crossing over parts of one solution for another and repeat it to find the best solution. Several years ago, I wrote a Sudoku solver that literally just took a Sudoku puzzle and tried to put in random numbers. And then it did another and did another and did another. And by creating 100 random solutions that weren't right, and by mutating and crossing over and keeping the ones that were good and doing it again, and keeping the ones that were better and doing it again, and keeping the ones that were better, it eventually grew the right answer. Um, it's just kind of a neat, again, way to use computers and use the power of computers and the power of repetition of a computer to solve a problem. Now, you really can't talk about artificial intelligence without talking about some of the ethical sides of things. You know, when we're creating artificial intelligences, when we're creating the future of computing, when we're doing this, we have to remember that AI is not a fix-all. It's not going to solve all of our problems. And we're going to have to always remember with an artificial intelligence, or as some science fiction authors call them, artificial stupids, we have to understand the complexity, the goals, and the environment of where that AI is going to be used, and what it's going to be exposed to. Um, and there are issues with every artificial intelligence. For instance, or intelligent systems, bias. If you have an expert system that was created by a group of experts, it's going to think like those experts. It's not going to think like other people. So it's going to have the bias of its creators. Um, that's always a concern. If you feed a neural network bad data, you train it badly, you don't give it good feedback, or you give it garbage data and again bad training, then it's going to be bad. It's going to be biased. It's not going to do a very good job. It's going to make mistakes. Now, some of these mistakes, like facial recognition on your smartphone to unlock your phone, you look at your phone and it doesn't unlock. Well, you hit your password and it unlocks. Well, that's not a huge problem if it makes mistakes. Well, if it lets people that aren't you into your phone, that could be a mistake. So, we always have to concern ourselves with the likelihood and the certainty that our AIs are going to make mistakes, but how bad are those mistakes going to be, and what are the implications of those mistakes if and when they're made? Artificial intelligence, as well as all technology, ethical issue we have to deal with is inequality. Wealth inequality is one of the big ones. The people that have the wealthy countries, the wealthy manufacturing companies, will have robots do the dangerous tasks. Will have artificial intelligences, expert systems to do the dangerous repetitive work, where in a lot of the world where there aren't resources, humans have to do those dangerous tasks. So there's certainly always going to be a wealth inequality when dealing with artificial intelligences. And we have to always consider the ethics of that. We also need to look at the impact on people. Um, and it's an impact of what it does to your daily life, but also what it does to your job. How many people in the automobile industry have been put out of business, have been put out of a job because we no longer do a lot of the assembly by hand, but it's done by robots and welding robots and painting robots. So the impact on people is an important part of any ethical issue when dealing with computers, specifically artificial intelligence or intelligent systems. And then lastly, the effect on the environment. Maybe the robot will make something more environmentally sustainable, but maybe that artificial intelligence or that our robot or whatever you're doing is going to use an inordinate amount of power compared to what it was like to do it without, or what kind of waste is being created in the creation of this AI or expert system or intelligent system. So we always have to balance biases in our systems, mistakes the system makes, and the impact of those mistakes, wealth inequality throughout the globe, the impact on people and society, and then the impact on the globe and the environment when wherever we're dealing with artificial intelligences. Just a quick aside that's not in the book, but I thought it would be kind of fun to discuss. 80 years ago, a science fiction author by the name of Isaac Asimov was writing a series of science fiction novels about robots. Um, and he came up with 3 rules to program into the robot's operating system, to program into the robot's hardware and software to ensure that the robot wouldn't, well, go off killing people. And rule number 1, first law, a robot must not injure a human being or through inaction allow a human being to come to harm. Well, that kind of makes sense. Of course, if you're building robots for war, that's going to have to violate that rule, aren't we? Um, Second law, a robot must obey orders given to it by a human being, except where orders would conflict with the first law. Okay, so a robot must do what it's told to do. And then the third law, a robot must protect its own existence as long as such protection doesn't conflict with the first or second law. So if it comes down to a robot or a human, the robot will kill itself for the human. If a robot is given orders, it will do it unless it's going to kill a human, but a robot could be given an order to kill itself and it would. So it's an interesting kind of idea. Now we're not to the point of autonomous systems and autonomous robots that have to live by these rules, but stop and think about uh, a self-driving automobile and the future of transportation, as many of us really see it happening in the next decade or two. You know, a car may not injure a human being or through an action allow a human to come to harm. Well, what about if it's a choice between a pedestrian, hit the pedestrian, or drive off a cliff and kill the person behind in the car? How's the car going to balance those two needs? Um, there's a case where where I don't know how the car would do, and what's the ethical thing one way or the other in that situation. What about artificial intelligences and expert systems being used for medical diagnostics? There are some artificial intelligence and expert systems that are really good at diagnosing cancer from MRIs. In fact, some of them are even better. But what about misdiagnoses? What about some of those other issues, the bias and the mistakes that artificial intelligence could make that could cause a human harm? That's interesting. And then what about the whole idea of machines of war? Um, you know, Terminators and fighting robots and robotic tanks and all of that kind of thing. Um, that's just I just think Isaac Asimov's laws were really kind of interesting to think about and how they impact the future. I just wanted you to think about the ethics of this. I just thought that was a fun aside to add to this presentation. So this concludes video number 13 on intelligent systems. Again, I'd like to say thank you for watching. And my name is Dr. Renaud from Shawnee State University. Remember, this presentation is copyright 2022 by me. All rights are reserved under copyright. And if you have any errors, discussion, or questions regarding the class or this video, please contact me at jrenaud@shawnee.edu and I'll get right back to you. Again, thanks for watching and I'll see you again.